Greetings. Next up, we're going to talk about proportions and proportionality. And so proportions, when we have two fractions or two ratios, and this is equal, the two fractions are equal, then that means their cross products will always also be equal at the diagonals. So we've done, you've probably done algebraic proportions, use proportions to solve other things. Proportions are used for many things, such as when we use a map, and the map is of course drawn to scale. So if the 6 inches between Lafayette and Vincennes on the map represents 160 inches in miles, then the 4.5 inches from Lafayette to Fort Wayne represents, we don't know how much, in miles. So we can always cross multiply and solve for x. We might also see a relationship between the numbers, but in this case we could say that 6x is equal to 720. And then when we divide, we get 120 miles. Now obviously this would just be like bird's eye, as the bird flies, as the crow flies, as opposed to actual roads, because there's probably not an exact road that does that. But it gives us an idea, and so that's how your scale on a map works. And so that is an application of proportion. Notice that below this on your paper, instead we could have set up Lafayette to Fort Wayne, and we could have done inches over inches equals miles over miles. So it's set up differently in that now it's not a rate, it's not inches per mile, it's inches to inches, miles to miles. But as long as we're consistent, like we did Fort Wayne top, Vincennes bottom, Fort Wayne top, Vincennes bottom, it's still 6 times x and 4.5 times 160. So we still get 6x, or 720. We still get 720 is equal to 6x, and so x is still 120. So that's one example of a time when we use proportion, is the scale of a map, or anything that's drawn to scale. So oftentimes if we have 3 quantities and we're looking for a 4th, we might be able to do that by using a proportion. You can do it in whichever order you like. I usually think inches to miles, personally. So between Evansville and Muncie, 8.75, and this is Evansville, Muncie. I'm going to put that up there. And then 4.5 Lafayette to Fort Wayne. And then this, when I set this up, when I see those first two, I can do whatever I want. In fact, I ended up doing inches to inches, right? These are both inches, but I have to set the other one up in the same way. So since I put Evansville to Muncie on the top, Evansville to Muncie has to be on the top. We don't know that, and we know the Lafayette to Fort Wayne. Okay, I also could have done 8.75. I don't know how much in real life. 4.5, I know represents 120. Notice in both cases that my cross partners are the same. So when we do 8.75 times 120, I get 1,050. So I have 4.5x is equal to 1,050, no matter which way I do it. So divide by 4.5 to get 233, round to the nearest mile, so 233 miles. All that extra 0.3333, we're just going to round that off to the nearest mile because that's what it told us to do. So here I've got pate and people. So 70 ounces of pate for 45 people. And then how many ounces? So I don't know the ounces. 315 people. So these are my ounces. These are my people. So now I'm going to, again, cross multiply. 70 times 315. 22,050. Divided by 45. So 490 ounces. Now, if you maybe recognize that 315 is 7 times 45, then you could do 7 times 70. You still get 490. So many, many things are proportional, like property taxes are based on the assessed value of a home. There are some additional exemptions and other things that can figure in, but in general. And so if I think tax and value, if you want to write value on the value on the top and the tax on the bottom, you can do that too, as long as you set both fractions, both ratios up the same way. So $1,600 on 73,000. How much, we don't know, is the tax if it's 87,500. Now, you could work with the numbers that you have here. You could take off equal numbers of zeros and do 16 over 730 and then work with it. You cannot come over here and chop off these two zeros on the 87,500 though, because we don't know what's in the top of that. Then we'll just cross multiply. And divide. And then round to the nearest dollar. So I would have anticipated dollars and cents, but the directions say round to the nearest dollar. So $1,918. Sorry about that. $1,918. And so think about if that seems reasonable. It should be more than the $1,600 because this house is worth $87,500. The other one was only $73,000. But it should not be a crazy amount more. It's not like double or anything. So you should have a good frame of reference of like, does this kind of feel right? It's not a guarantee that you rounded correctly, but for instance, if you tried to cancel off zeros that you couldn't, then maybe you got like $19.18. That would not be right. Or maybe you got $19,000. That would not be right. Or if you flip-flopped it somehow when you set it up, you would get something that would be so wrong that you should notice if you give it the reasonable test. So 1 acre, 30,000 plants. How many on 17 acres? So in this case, since it's only 1 acre, dividing something by 1 is not going to do anything to change things. So in this case, since this is just 1, we can simply do 30,000 times 17. But again, would not be incorrect to set it up this way. But what would happen? We would do 30,000 times 17. So Larry is creating a mural from a photograph. Every ½ inch of the photo will be equal 4 inches in the mural. So I've got the photo and the mural. That's how I'm going to think of this. So the photo, 0.5, will be 4, represents 4. So if the photograph is 7 inches wide, that's the photograph, that's why I put it on top. We were trying to find out how much will that be in the mural. So again, I can cross multiply. 0.5x is equal to 28. So when I divide, I get x is 56 inches. Now, you could cross multiply. You could have thought, oh, ½ inch to 4 inches, that's 8 times as big. So 8 times 7 also gives me 56. So more than one way to get to these answers, but the proportion is a good and reliable way, even when you don't see some other relationship between the numbers, or when it would come out really messy. So these next couple problems I'm not going to work out, I'm just going to set them up, but I think they give us a great idea of the variety of applications that we might see using proportions. So if her tuition is just per credit hour, then for 15 credit hours, if she spent this, and again, you could set this up the other way. If you like to figure out like how many dollars per credit hour, you could put dollars on top. But if all I need is how much her tuition is going to be, notice the 11's on top because it's credit hours, and the dollars, how much the tuition will be, is on the bottom. And then this doesn't tell us what to round to, so it would be appropriate to round to dollars and cents, as they gave the original tuition in dollars and cents. And then we have medication. So if any of you are thinking about pharmacy tech, that is a certification you could do, and use lots of proportions to decide how much medicine someone needs or how many pills they need, all sorts of things. So this is basically the weight and the antibiotics, or you could put the pounds and the milligrams. So the 35-pound child gets 525 milligrams at the same rate. It says the dose is proportional to body weight. If the child weighs 68 pounds, so notice pounds was on top, pounds is on top. We don't know how much medicine. And then again, still cross multiply and divide. In this case it says round to the nearest milligram, but as a quick estimate, I'm going to say it's somewhere close to 1,000 milligrams, because 68 is almost 2 times 35. Okay, not quite, but almost. And 2 times 525 would be 1,050. So your answer should be ballpark 1,000 milligrams. So if I get something that's far away from 1,000, I know something has gone wrong. All right, so that is some beginning information about proportions. If you took, depending on when, but you may have done a lot of work with proportions in my algebra class or in my pre-algebra class. We did a lot of that. And then what comes up next in your packet are some practice. And these are practice pages with scientific notation, per capita, some per capita that we have to scale, where we're going to scale it up to per 10,000, per 100,000, per million, and then there are some proportions. Okay, so I would like you to work through, so you're going to stop at the applications page. So get a little bit of practice with the different things that we did in that section. And then you may also, perhaps not, that's kind of, those are our practice, like our homework assignment part. And then there is a separate homework assignment after we have done this next section, but that'll be a different video. All right, so this just rounds out section 3. Thanks.